Hi, my name is Lane Mudd. I'm a human resource and business management major, and this is my BDAN Capstone project. I'm going to be walking through my two data sets and explaining how I built and evaluated my models using R. So for the first data set that I have is the body measurements, and this is the chart that I just imported. So now I'm going to be going to the script. So what we're first going to do is I'm going to be highlighting these four lines, and these are the packages that I'm going to be loading. This line lets me import Excel files, while this line helps with the data cleaning. This line is for the decision tree, and this line helps with the splitting the data and evaluating models performance. So what I'm going to do is I'm going to run all four of these lines. And after running it in the console, it confirms that the packages were loaded correctly. So now what we're going to be doing is reading the data. So I'm going to highlight this line, and this line loads the body measurements data set so I can work with it in R. So I'm going to be running this line, and after running this line, this confirms that the data set was loaded successfully. So what we're going to be doing now is viewing the data, which I'm going to highlight these two lines right here. And these two lines let me preview the structure of the data set and see basic summary statistics. So I'm going to run these two lines. And as you could see after running these two lines, this confirms that the variables and values look correct. All right, so now what we're going to be going over is the train and set split, which is these lines right here. And here I split the data set into 70% training data and 30% testing data. The model learns from the training set, and I test its accuracy using the testing set. So what I'm going to be doing is I'm going to be running all four of these lines. And after running them, now that the data is split and it's ready for modeling. So what we're going to be doing now is going over the linear regression, which is these two lines right here. And this is my first model. It's a linear regression that predicts body fat using other body measurements. I excluded density because it already directly relates to body fat. So what I'm going to be doing is running these two lines, excuse me, and after running them, this output shows how each variable affects body fat and confirms that the linear regression model ran successfully. So what we're going to be going over now is the prediction and performance, which is just these three lines right here. And these lines generate predictions and then calculates the RMSE and the R squared. The RMSE tells me how far off the predictions are on an average, and R squared tells me how well the models explain body fat. So what I'm going to be doing is running these three lines, and after running these lines, these values show how accurate the linear regression model is. So what I'm going to be going over now is the decision tree, which is just this line right here. And this is my second model. It's a decision tree that predicts body fat by splitting the data into different groups. So I'm going to be running this line right here. And this confirms that the decision tree model was created successfully. So now what we're going to be doing is I'm going to be I'm going to be running these three lines right here. And these lines evaluate the tree model using RMSE and R squared, so I can compare its accuracy to the linear regression. So I'm going to be running these three lines. All right, and after running these lines, these values show how accurate the tree model is. So what I'm going to be doing now is I'm going to be going over the model comparison, which is just these two lines right here. And actually, it's these two lines right here. I'm so sorry. And these lines compare the two models that determine which one performed better. So I'm gonna run this line. All right, and then this line. All right, as you can see, by comparing these values, I can decide which model performed better for predicting body fat, which as you can see, it was this one. Okay, so now since we're done with the body measurement Excel file, we're going to be moving over to the loan application file. So what I'll be doing is clicking this and importing data set. Awesome. So now what we're going to be doing is going over to the loan results script that I have. And the first thing that we're going to be doing is we're going to be running this line. This data set contains loan application information, and the goal is to predict whether a loan is approved or not. So we'll be running this line first. And after running this line, this confirms that the loan data set loaded correctly. So now what we're going to be doing is convert to factor. So the lines that we'll be running are these lines right here. And these lines convert categorical variables into factors so the models pr process them correctly or process them correctly. I'm so sorry. All right, so I'm gonna be running these lines, and we're also gonna be running this line as well. Awesome. So after running those lines, this confirms that the categorical variables were converted properly. So now what we're going to be doing is going over the train set split, which I'll be having to run these lines right here. And once again, I split the data set into training and testing sets so I can measure how accurate the models are. So I'm going to be running these lines. And after running these lines, the loan data is split and ready for modeling. So now what we're going to be doing is running these lines right here. And because the loan approval is a yes or no outcome, I use logistics regression instead of regular regression. So I'm going to run this line and I'm going to run this line as well. So after running those, this confirms that the logistic regression models ran successfully. So what we're going to be going over now is the predictions and the confusion matrix, which I will be having to run these three lines right here. And these lines generate predictions and then creates a confusion matrix that shows how many approval and denials were predicted correctly. So I'm going to run these three lines. And as you can see, after running these lines, this confusion matrix shows that the accuracy of the logistic regression models, as you can see in the console and in the environment. So what we'll be doing now is going over the decision tree, which the decision tree is this line right here. And this is my second classification model, a decision tree that predicts loan approval based on the applicant's characteristics. So I'll be running, which I'm also going to run this line as well, and then this line. Perfect. And after running that, this confirms that the decision tree classification model was created successfully. So now what we're going to be doing is we're going to be running this line right here, and we're going to be running this line as well, which this confusion matrix shows that the decision tree accuracy, which I compare to the logistic regression. So I'm going to be rerunning these two lines. Awesome. And after running these, now I can compare the decision tree accuracy with the logistic regression accuracy to see which one performed better, as you can see in the console. All right, so overall, I successfully built and evaluated two different models for each data set. I compared model performance using accuracy, RMSE, and R squared to determine which models performed best. Thank you for watching.